Okay, so we're on number 4, so we're still trying to write an explicit formula. So remember, if it's arithmetic or geometric, we can refer to that formula sheet. So they actually give us the recursive formula this time. And they wrote it a little bit different, which is nice because we can take a look at this. So this says a sub n plus 1, and this says a sub n. So a lot of times we saw the a sub n minus 1. But think about it, if this is a sub n plus 1, a sub n would still be our previous term. So they're saying you're doing 5 times the previous term. So in order for us to get this, I would like to write out the sequence. So the first term we know is 7, and it's saying 7 or 5 times the previous term. So 5 times 7 is 35. Then 35 times 5 give you 1,225, and then if you multiply that times 5. Okay, so what we're doing here, each time we're multiplying by 5. Now, you didn't really have to write out these terms, because right here told you that each time you're multiplying by 5. So, because we are multiplying by 5 each time, we know this is going to be a geometric. So we can refer to our formula sheet. If we look under geometric, our sequence formula is a sub n equals a sub 1 times r to the n minus 1. So we're going to have a sub n equals, we know that our first term is 7. Our ratio is what you're multiplying by. We're multiplying by 5, and that's the n minus 1. So this is our explicit formula. We actually went from recursive to writing the explicit formula. And you didn't really have to do this step because they told you the first term and this is what you're multiplying by. But it's not going to hurt to write out a few terms there. Alright, so next, they want us to write out the first 5 terms, but this time they're saying assume that n begins with 0, so sometimes that can happen. This is called an explicit formula because they're just n's, they don't depend on anything. We are starting at n equals 0, so when you get your technical first term, you're doing a sub 0. So 2 to the 0 over 0 factorial. Well, anything to the 0 power is 1, and remember I told you 0 factorial is 1, so the first term is going to be 1. Then we'll plug in 1. Which will give us 2, and then we can plug in 2, which will also give us 2, and we can plug in 3, which will give us 4/3, and they want us to get the first 5 terms, so we can plug in 4. So the main thing for you to see on this problem was that it won't always start at 1. If it doesn't tell you, you can assume that it starts at 1. But sometimes they'll tell you that it starts at 0, or it might even like start at 5 or something. Just if they don't tell you, assume that it starts at 1. But if they tell you, just make sure you start with that n value. So those are going to be our first 5 terms of that sequence. Alright, we're going to shift gears a little bit here. So all we talked about so far are sequences. Sequences are just a list of numbers in some type of order. Now we're going to be talking about a sum. So sum means that you're adding these things up. So the symbol that we're going to use for sum is sigma. So whenever you see that sigma, that means we're talking about a sum. So guys, I want to just kind of, before we go to this, like if I give you the sequence 2, 4, 6, 8, 10, yada yada. This is a sequence, but if I do the sum of this, now I'm saying I'm adding all these numbers together, and it would keep adding up forever. So this is a sequence. This is a sum. Okay, so that's the difference. Alright, so for the first ones, we want to find the sum without the calculator, and then I'm going to show you how to do it on the calculator, even if you don't have a calculator, in case you see it in the future somewhere. You'll have it. And we are using a different variable here. It doesn't matter what variable they use. It all works the same. So what you're going to do here is, because this is the sum, we are going to be adding everything up at the end. But before we can add, we need to just find the sequence. So it tells you that it starts at 1. So that means you're going to plug in 1 to the equation they give you here first. And then you're going to plug in 2. You're going to plug in 3, and the last number you're going to plug in is 4. So this tells you where to start plugging in, and this tells you where to stop plugging in. Okay? So we're going to plug in 2, plug in 3, plug in 4. So once again, the bottom number tells you where to start plugging in, the top number tells you where to stop. So we have 5, 8, 11, and 14. So because we have this sigma here, this tells you we want to sum these numbers together. So we're going to add these numbers together. And it will give you a sum of 38. Okay? So then number 7. Okay, so it tells you we're going to start plugging in at 1. And we're going to stop plugging in at 5. The only problem is there is nowhere to plug in. So if you were to plug in 1, since there's nowhere to plug in, that'll give you a 12. If you were to plug in 2, that'll give you a 12. Plug in 3, that'll give you 12. Plug in 4, that'll give you 12. Plug in 5, that'll give you 12. So you plugged in 1, 2, 3, 4, 5. Because this is a sigma, and that means you want to find the sum, we are going to add these 12s together. So if you add 12 together 5 times, that will give you a sum of 60. So, I do want to show you how to do this in the calculator real quick. We can just check our answers. So, if you have a calculator, you can take a look at this. If not, on the ones that say calculator problems, you can just either do them by hand or you can just kind of ignore those for today. So, we're going to go to math and we're going to go to 0 and it should bring up the sigma. So, I'm going to put an X and I'm going to do number 6 first. So, X starts at 1. And the top number needs to be 4. And then in the inside, I would type in 3x plus 2. And if I hit enter, I got 38, which is exactly what I got for number 6. So for number 7, I'm going to hit math, go to 0, x equals 1. The top number is 5, and the equation here is just 12. And you should get that 60. Okay? So these can be done on the calculator, or they can be done by hand. Alright, so there's not a number 8 on here, it just skips to number 9. And we want to rewrite the sum using sigma notation. So we're going backwards here. So let me write this out. So what we want to do here is we want to just treat this as a sequence first. Okay? So think about how we do sequences, and we're going to use maybe our formulas, the explicit formulas. So we need to figure out what's happening from term to term to term. So we have 2, then we go to -8, then we go to 32. So hopefully you're thinking about we are multiplying by -4. Well, if we're multiplying by a number, that means it's a geometric sequence, or in this case, series. Okay, guys, sum and series mean the same thing. So if you hear me refer to that. So if we look at our formula sheet for geometric, we know that a sub n equals a sub 1 times r to the n minus 1. Okay, so I'm just pretending like this is a sequence right now. So we know a sub 1 is 2. The ratio we just said is -4 because that's what you're multiplying by to the n minus 1. So if this was just a sequence and not a sum or a series, that's how you would write the sequence. But it wants us to put it in sigma notation. So we're going to write our sigma. You can use whatever letter you want to use. I'm going to use n. So n equals, now look, it started at n equals 1. So I'm going to put n equals 1 here. And to figure out where it stops, this is n equals 2, n equals 3, n equals 4, n equals 5, n equals 6. So we have to put a 6 on top to show where it stops. And then in the inside, you're just going to put the equation that you found for that sequence. So this right here is how you rewrite that in that sigma notation. Okay? So we figured out it was geometric, so you make your formula. Then you can put it inside of your sigma. You just have to put where it starts and where it stops. Okay? And then our last problem for this lesson . Okay, so first off, they're not all fractions, so I'll make them all fractions. So if you look at the fractions, so from 1 to 1/2 to 1/3, there's really nothing that you can add or subtract to get there. So I want you to think about the patterns. So if we want to write just our formula for our sequence, if you notice they all have a 1 on top. So then I'm going to label this. This will be n equals 1, n equals 2, n equals 3, n equals 4, n equals 5. So in the denominator, hopefully you notice these just go together. So it's just going to be 1 over n. Okay? So we need to write this in sigma form because we are adding these together. We have a sum which is called a series. Okay? Let's say that again. Sum and series are the same thing. Okay? You're adding them together. Okay, so we're going to put our 1 over n inside. We just have to tell it where to start and stop. So we're starting at 1. So n equals 1. Now, it doesn't stop at this 5. It actually goes to 15. Well, we already know that that's the n value here. So we know it's going to go to n equals 15. So you're going to have 15 on top of your sigma there. So it's going to be sigma notation from 1 to 15 of 1 over n.